Okay, so in this video, what we're going to do is we're going to take our tiles that you've created as part of the last exercise and then start turning them into a bit of a map. In this example, currently, we've just got the flashing tile, and what we need to do is to start building this up into more of a map, which will go along those kinds of lines. Okay, so this now means we have to introduce some code. Now, usually when I'm working on a game, I would do this in separate file, an ActionScript file, but for now we're just going to work inside the same document. So we will have a layer on the main timeline. I've called it code because all that will be in it is code. I can delete the tile from the stage because we don't need that. But in the library here, we need to make this tile accessible to the ActionScript that we're going to use, ActionScript being the language we're working with. So there's a column that says linkage next to game tile, which represents the movie clip. And I need to double click on it and call it tile. I'm calling it tile with a capital T because this is essentially a class, something that is reusable. And the convention is always call your classes with a capital letter, the first word. In fact, there should only really be one word if you can help it. So this will construct our tile. Then on the main timeline, on the first keyframe, I'm going to insert some actions. And the way to get actions up is F9 or window actions. And this is already available to me. So what I'm going to do is just open that up. And you can hide it away a couple of ways by clicking on that. And the code that I've created, okay. So, technically speaking, what we'll actually need to do is import the class eventually. But while we're working in the practice mode, it's not going to matter too much. So, we're going to work with variables. So you will see on quite a few lines the keyword var. Var declares a variable. A variable is something that holds information, holds data, can hold all sorts of data types. In this case, we've got an array, which is essentially a list. Our practice map is going to be a list that stores the positions of the tiles and the type of tile that we're going to use. It's just a list. And then we're going to have a variable that contains an integer, which is the tile width and the tile height. The reason we store this information rather than just using the number is if we change the tile width and tile height, we only really need to change these variables to update the code rather than having to go through and change the number in every place. And then we're accessing practice map here to tell it what it's going to contain. There's a square bracket here and here, which is the first level of practice map. Now, the way the list works is there's actually two items in practice map. This here is item 1, and this here is item 2. Although the way that ActionScript counts is it counts from 0, as most coding languages do. So this is 0, and this is 1. And these correspond to the rows that we are going to see on the screen. Now, strictly speaking, we can't use 0 as a number, and we're going to reference the tile because a movie clip doesn't have a frame 0. It has a frame 1, however. In my clip now, it's got a frame 2 as well. So in writing our list out in this way, we're making it a little bit more visually understandable as to what's going to appear on the stage. I've got a row, which is just made up of frame 1 of the tile. And the next row is made up of frame 2, which is a wall with one little gap in it, which is the grass clip. I've then created a function. A function is a bit like a recipe. It sets instructions, a method, and when you call that function by its name, in this case set location, trying to use meaningful names, what it will do is it will run that list of instructions. So we've got a set of instructions, and this might seem quite complex. The first thing to know about a function is it has a curly bracket at the start to define its start and a curly bracket at the end. there are some normal brackets, and these define if we need to send any information to that function when we call it. In this case, we're not going to, but eventually we probably will. We've then got some conditions, and we're using a keyword called for. And inside of the condition for this for, we can set a number. So we set a variable called I to 0. And we're going to use that number to count. It will get bigger every time until it is no longer less than the length of practice map. Practice map has 2 items, so it will go 0, 1. So that will go 0 and then 1, and then when it reaches 2, it will stop. This just means that when it's run through this cycle once, it will then make I bigger. So inside of this condition, which is set by curly bracket there and there matched, there is another variable, tile y. And this is the I, this number here, times by the tile height, which is something we defined at the start. What that means is when we get to the end of the first run through, it will make I times tile height get bigger. So we go through index 0, and I times tile height is equal to 0, because 0 times 64 equals nothing. But when we get to row 2, which is indexed as number 1, remember counting 0, 1, that will mean 1 times 64, the position of the tiles then will be 64 in the y-axis. So that means they will be positioned 64 pixels down from the top. In doing so, we can then run and loop through the first part of the practice map array. So what's going on here is we're creating another for loop, and this is going for a new variable called j. So we're going to count using another variable called j, which starts at 0 and is based upon the length of practice map I. And what that means is whatever is inside of, so there's an array here which contains 10 values, and another array here contains 10 values, and they're contained within the practice map array. So it's a list of a list. In doing so, it allows us to create, as I say, a visual representation or a more visual representation of our map in numbers, which makes it easier to understand when we actually run this code. So there's 10 elements. What that means is this will equal 10. So it will run from 0 through to 9, because once it reaches 10, j will no longer be less than that number. J will continue to get bigger. And what it's doing is it's taking the tile x, which is an integer, or creating a variable called tile x, which we're going to use to position it. It's taking j and timesing it by tile width. So j, to start off with, in this row, for example, will equal 0. The first index is 0. So 0 times 64 is 0. The next one is 1. 1 times 64 is 64. 2 times 64, 128. So the first tile will be positioned at 0, the second tile will be positioned at 64 pixels, and the third tile at 128. So it's continuously moving the tile across until it gets to the point where it reaches index number 9, and then it will return to this loop here. Tile Y will get bigger by 1, and we'll move on to this row here. So then tile Y will go from being 0 to 64, and it will run through this loop again, running from 0 through to 9. And so in practice, if we just look at that again, we can see each one of these tiles, which is linked together, has moved across to create something looking like a level. It's only the first 2 lines of the level. And then what we need to do is to actually make this happen. So when we called our tile in the library through the linkage name tile, what that meant was we can add a new tile at any given point in time using ActionScript. So we've set the positions where they're going to live. We then need to create a variable to hold the new tile. So a new tile is just a name that we use to refer to it. And then we've got the keyword new, which means create a new one of this tile, which refers to this. So it'll bring from the library a new tile. When we add child new tile, what that does is it makes it appear on the stage. Without this line, nothing will appear. although strictly speaking in memory, they exist and are in position. So that's a very important line, add child. If you don't do that, nothing will be there. And that's a good thing to look for if it's not working. We then position it based upon tile X, which we've declared here, every time that gets bigger based on J, and tile Y, which gets bigger here based on the variable I. So we're positioning the tiles in their X and Y coordinates, and then we are also telling it very simply at this point where to go to and stop. Now, there are different ways of achieving this, but we're using one movie clip with several frames in, and those frame numbers will be the reference for the tile that we're looking at. So go to and stop. It then looks at practice map. It looks at practice map here. It takes the number I, so we know that it's in, to start off with, 0, and then it finds out J to find the location within that. So an example would be if I is equal to 0 the first time it runs and J is equal to 3, and then we go look at the map. So 0 is this first block, 0, 1, 2, 3. We know that that's going to be a tile of 1, which is grass in this instance. To add new rows, we then put a comma in, and we can just copy and paste line there and change the numbers. So I could put 1 there, and 1 at the end, and we should now have 3 rows. There we go, 3 rows, and you can see the new elements that have been created. Okay, so we'll end the video at that point. I'll just make the code window a little bit bigger. So the last line in the code is that we set location. Set location then runs this function and makes everything happen.